So this was a problem I got wrong on the exam, so I just wanted to go over it to kind of explain where I got points off. And so for part A of this problem, it was clear that E1 is less than E2, but they are going in the wrong direction. So it should actually be E1 should be in the opposite direction as I drew it. And so it'll be that way all across. E1 and E1, E1. And E2 will also be in the opposite direction. So E2, and given that, we know that the velocity is in the opposite direction as the electron, it's the electron, so we know that V2 is this way, and likewise, V1 will also be this way. And so that kind of solves A and B. Moving on to the next part, I kind of used the wrong formula to describe this, even though the rules were correct. And so for part C, when we're finding the drift of V1, we know that I is equal to N, A1, V1 is equal to N, A2, V2. So we know that V1 is equal to A2 over A1 times V2. We also know from the formula, which I kind of explained here, which is the same, EMF is equal to E1 L1 plus E2 L2, which we can then say is equal to V1 over U L1 plus V2 over U L2. Can simplify that to 1 over U, A2 over A1 L1 plus L2 times V2. And so when we plug in the numbers, we get V2 is equal to EMF times U over A2 over A1 L1 plus L2. We plug in the respective values and we get V2 is equal to 1.24 E negative 4 meters per second. And so since we have V2, we have the formula for V1 above, we plug in the numbers and it's equal to 3E8 over 4E negative 7 times 1.24 E negative 4, which is the number we just found. We get 9.3 E negative 6 meters per second. So we have our values for V2 and V1. So for part D, where it asks how many electrons per second, we just use the formula I equals N A1 V1 is equal to 6E28, 4E negative 7 times 9.3 E negative 6. And that gives us 2.23 E17. And that's the end. Thank you.